Hello, this is presentation on the project our group is currently working on, which is called Generating Reviews for Call Products. So what are the call products? The reviews nowadays are the important part of the customer purchasing decision. People are more likely to buy the product that has reviews on it. Let's take a look at the Amazon website. When we enter any shopping website, we can see that some products have a lot of reviews on them. These products are called warm products, like picture on the left. Other newly released products don't have any or sufficient amount reviews. These are named as call products. We can see them on the picture on the right. The goal of this project is to generate reviews for call products from the reviews of warm products. For this purpose, the sentences from the products with sufficient amount reviews would be selected, and the reviews that are close to the actual reviews written by the users would be generated. This would help users to understand product features and get overall people opinion on these features. Beyond that, manufacturers of the new products could predict the customer opinion on the products before they are released and react to the predicted feedback in advance. When we obtain the reviews, we need to see if the reviews are actually relevant. For this, we can take warm products and remove the reviews from it. Then method that is used for review generating will be applied to this product. The obtained result will be compared with the actual reviews. To compare two sets of the reviews, we can use Rouge-N matrix, where N is the number showing how many subsequent words are common between two sentences. The most commonly used metric is Rouge-2, that shows how many pairs of subsequent words can be found. Topic modeling techniques are methods in natural language processing that extract the underlying topics from the given set of the documents that were used to generate these documents. So the goal of topic modeling is to identify topics that were used to generate the set of documents. For example, if we go to the concert and then we want to write the report about the concert, we first would think about the content of our report. The first paragraph could discuss the music and the second paragraph could be about the show. Therefore, we have two topics that are music and show. When we know the topics, we can create sentences that represent these topics. The topic modeling finds the topics that would be generated by people. The mathematical model that replicates the process of the generating sentences was created. The algorithm takes a look at the documents and gives a list of topics for each document. In this project, we use the reviews. Each review is the document that is made from the words. The set of all words that is absorbed in the documents is vocabulary. And collection of documents is called corpus. Topic modeling is applied in this project latent Dirichlet allocation, or LDA. LDA creates two probability distributions. The first distribution is called topic modeling distribution. For example, we have 1000 documents in the corpus. We take document 5 and we want to know what topics were used to generate document 5. The algorithm would tell us, for example, the topic 20 and topic 76 were used. So it shows distribution of topics over the documents. The second distribution that LDA learns for us is distribution of topics vocabulary. For instance, we have topic zoo. Probability of meeting words that are related with animals would be much higher. So it will show how topics are distributed over the vocabulary. However, LDA is not intelligent enough to decide how many topics there are in the corpus. Therefore, we have to tell LDA the number of topics. If chosen number of topics is too large, then LDA could start splitting the topics into subtopics that don't make sense. If there are too few topics, then it merges the topics together and we would get very general topics. So we input the corpus to LDA, and as output we will get two probability distributions. If we have 50 topics, LDA could say, for example, the topic 1 has a 50% of chance of being used, topic 2 has a 2% chance of being used, and topic 3 has 7% chance of being used. The sum of all probabilities would add up to 1. We sort the topics then in descending order, and the topics that have highest probability were used to generate the documents. LDA has implementation in the Python's GenSim package. GenSim extracts semantic topics from the documents. Semantic topics are the topics that are similar or have related meaning. To make a corpus easier to work with, preprocessing was applied. Tokenization splitted sentences into the words. All the words were converted to lowercase. Commonly used words were removed by storing a list of words that are considered to be stop words. GenSim has a language detection technique. The list of English stop words was created in the project. Frequency technique removed the words that are uncommon, and stemming removed words, prefixes, and suffixes. Then, preprocessed corpus were stored into the dictionary. After the corpus were preprocessed, we can present a text in the corpus in vector form, so it can be manipulated mathematically. We take a document collection, find a set of unique words within the corpus, then we order them alphabetically, and then we give them an index. Neural word embedding takes the words and embeds them in vector space. Word2Vec is a technique for neural word embedding. It took our reviews as an input and a generated vector for each word in the corpus. The words with similar meanings had similar vectors. However, we need vector representation per the document and not per word, so each review would be a vector. Therefore, vectors of words were added in the documents and then they were averaged. So if we have 5 words in the document, we have 5 vectors, and the average of these vectors is the vector representation of the document. The vector representation of each document will be the location that corresponds to the words of the document. This location was represented as 1, anything else was 0. So now we have vector representation for words and the documents. Next, the cosine similarity between the documents were calculated. It showed how 2 vectors are similar. For instance, we have 2 documents. First document has words apple and sunshine. Second document has words apple and car. If we check vectors, apple is the first element of both vectors, and it's also a similar element. When cosine similarity is applied, the element 1 of the first vector and the element 1 of the second vector would be multiplied together. Anything else would become 0. Cosine similarity would become a very small number. However, there is a problem. If the first document is I love oranges and the second document is I love apples, there would be no similarity between them, even though there is obvious similarity. Therefore, the words with semantic similarity were placed closer to each other. If the corpus is too large, the vector becomes huge, with a lot of zeros in it. Thus, smaller vector was created. The deliverable for this semester was to obtain LDA model, graph construction, and clustering, as well as representation of Word2Vec graph and clustering over it. LDA model was generated for each document. It was sorted based on probability. Topics were generated. For each review in the corpus, 1 node was created. If 2 documents shared at least 1 topic, the link was created. At the end, we got the graph representing all the documents, and the links between them represent the topics that are similar. NetworkX package of GenSim allowed to visualize it. After calculation of vectors cosine similarity, if it was below the average weight, the edge between the documents were removed. Then clustering technique from NetworkX were run. The clustering technique produced the set of clusters. The documents that are similar to each other were grouped together and they were close in space. The reviews that are similar could be observed within a cluster, and the reviews that are different could be seen outside of the cluster. Here we can see the clustering of LDA and word embedding clusters. The presentation is coming to the end. I would like to add that the future step of the project will include grouping the reviews that are relevant to the products. The tools that were learned this semester, such as word embedding, topic modeling, graph clustering, will be applied to the practice. Thank you very much for your attention.